So we've got basically two main functions that the IDE or compiler expects to see in terms of in the Arduino environment. And we talked about the fact that this is not necessarily always true, because you can still use int main and it will work because it's built on C. Not every microcontroller, even though this is based on AVR and is backwards compatible with all the AVR programming interfaces or programming language, or programming language of scope, is not necessarily the case when it comes to the void setup in the function. So this, you can't necessarily use this in a standard AVR programming environment. So two key functions, void setup, void loop. The setup, all your configurations go in here. And before the setup, if you've got global variable declarations, you can tell from last time when we used the const keyword, if you define a variable as global, it means other other functions or the functions in your code have access to it. If you define it local, then only the function that is defined in has access. We have mentioned that if you go to the Arduino reference page, it gives you access to all the functions that you're using. So if you're not very sure about how a function is used or its declaration, you can get a bit of information there, right? And the loop function, you've already seen this LED blinking code, and we've talked about how the loop function works. And in terms of declaration of functions, like basically these setup and loops are functions. So the setup returns nothing, so it's of a void data type, and because it takes no parameter in there, it's also blank, we can basically put void in there and it will still work. If you are actually if you create a function, let's say, that finds the square of a number, and you call the function square, give it whatever name, it takes an integer as an input. So you have int x as, or int variable name as a parameter in there, because it takes an integer as input and the logic will work with it. And also it will definitely return the square of a number. So the return type should be an integer or float, or the data type in there, rather than void. That gives us a bit of info about functions. You've got a bit of example in there for you. And with the curly brace, so opening, closing, everything in here belongs to the same scope or belongs to the same construct. So that gives us a bit of info about the curly brace. And of course, if you end of a statement is the semicolon, so you can have int x equals 13, int y equals blah, 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 int z equals, all on the same line, as long as you have the semicolon separating them. That's completely okay. Another way of defining it is a concatenated way. So you can have int x, y, z, comma this, and you can have equal sign on there. We have already used comments. We've used single line comments, which is just simple slash, then we'll comment only one line. And we've used block comments, the beginning and the end. You have already used block comments to define, to create your header. And I said every circuit you create, please have your own style of header, copy it across for every single circuit you create. It's one way of sort of saying, taking credit for your work as well. Variables, simply containers. So variables are set containers, and in memory, variables do occupy space. So you have different type of container. The bigger your container, the bigger the space that it will take. And how does it actually, how do we determine the space in memory that these variables take? So integer data type, integer is the data types, and hence basically using different data types, we can have different types of variables, and we can talk a bit more about it. We've already talked about analog and digital, so if you've already done the RGB stuff, you are using the digital read function already. If else statement, decisions and other things, we'll come back to them later. So the variable declaration, the int or definition will be the data type and the name you give it. There are golden rules, and the C++ golden rules apply to them. You can't define a variable starting with a number or a special character. You can't give a variable name as a special character. So I can't have int if, for example, int else, because else are reserved names for instructions, and special characters like at input variable. You can start with an underscore, or can have an underscore in between and other things. So they are proper names, and of course they are case sensitive, so you have to be careful of that. So input variable is not the same as capital input variable. We've talked about the variable scope, global variables, local variables, and we have already used the for loop before at some point. Then take us to the data types. So data types, we have a byte. Zoom in. Byte is quite similar to, as the name says, basically 8 bits make a byte. And a char data type, character data type like M, making use of the ASCII code. So if you have the ASCII codes or ASCII code standard representation of the characters on your keyboard and all the special characters in there, you only have a handful of information that you want to represent. You can do your ASCII code and give you the ASCII code. Hence, 2 to the power 8 is enough to represent special characters. So the same way a byte occupies 8 bits in memory, which gives you possibly 2 to the power 8 combination, which is 0 to 255, which basically is 256 possible combination. The same as a character, so M, like Michael, I need only 8 bits to represent M, Michael. And of course, if you have like an array of characters, you have a string, and hence M-I-C-H-A-E-L. And a string actually in the Arduino environment is an object. So wherever possible, if you don't need to use a string, don't use a string. And an integer occupies twice as much space as byte or character data type. So an integer uses 16 bits, which gives us 2 to the power 16 possible combinations, and the value 2 to the power 16 divided by 2 will give you this range, starting from the minimum range from a negative value to the positive value. So of course it will be -1 in terms of the actual data or actual value you get when you get 2 to the power 16 divided by 2. Now the interesting thing here is something that's worth noting. Things like the early Pac-Man games, because they didn't take into consideration that people will reach a certain score, a certain level. When people reached that level, actually they were getting a bit of some jitters in the screen and all that, because they didn't take the data type and memory considerations into consideration properly. So if you if you have an integer, integer data, a variable of integer data type, and you assign a value or do a calculation that exceeds 32,767, it will overflow to the minimum value. So if I do 32,767 plus 1, the next value will not be 68, but it's going to be -32. So that's something worth noting. Otherwise, you're likely to have runtime errors, and runtime errors are very difficult to debug because your code's going to get really big, and then you're going to have to spend a lot of time trying to figure out why your hardware is not behaving the way it should, right? The general purpose process and everything, the large computing, we have a lot of flexibility when it comes to memory, but when it goes to the microcontroller level, they are basically mostly designed for small applications and or just simple applications. They have limited memory. I think the Uno R3 80 megabyte 28p has only about 2K memory, which is very small compared to what the terabytes and the terabytes you're talking about. So when you're creating programs, you need to bear in mind whenever you can use the smallest number of integer, wherever possible, or data type, sorry, just use the data type that occupies the smallest memory. So long gives you 32-bit. So you have 32-bit memory space, which gives you 2 to the power 32, and again 2 to the power 32 divided by 2, similar to what we did with the integer. And when you add 1 to this, you will get an overflow coming down. Floating point, you need some number of ones and zeros, bytes, to represent the precisions or number after the decimal point. So if I do quick question, right? Quick question. If I define x as an integer, x is an integer, and the value of x is 5, and y as an integer, and I say y equals x divided by 2, and the values are x, and I'm divided by 2, and both x value is 5, both x and y are integer, what do we expect the value of y to be? The variables are basically just containers. So if you keep pouring marbles into this container and the marbles you pour in is just more than the container can handle, everything else will fall outside it pretty much, right? So basically we just truncate the decimal point, everything after the decimal point out. So that's also another possible source of runtime error, if things that you need to be aware of. So if you're doing calculations that you're likely to end up with floating point data, best to define your work the variable as a floating point data type. Or you can do typecasting, which is putting the float into bracket, and you do a typecasting to get what you want the assignment should be. Right, then arrays, we've already talked about array of characters being strings, and of course how you define arrays. You ought to be careful here when you're creating large programs or applications or games or those kind of things. If you have array of strings, you are likely to run out of memory, not array of characters, because strings are objects in nature. You're likely to run out of memory completely before or use more memory than the Arduino can handle. Right, arithmetic operations, plus, minus, multiply, divide. There is a percentage sign for modulus. So quite similar to normal mathematics, arithmetic operations or arithmetic operations in other languages. Then there is the plus plus, which is the same as x equals x plus 1. We know where C plus plus got its name, the plus plus side of it. And of course, there is the plus plus x that you can have alternative as well. The good thing with the practicals we do is that you can test all these in software and see it working and see how the output looks like. All right, I'm going to end it there. I know it's a recap, so we had sort of a really quick recap about things that we know or hopefully know already. Even if we didn't, we've had a chance to talk about them.